Hi, in this video we're going to look at surface area of revolution using MATLAB. So the formula for finding surface areas is right here. It's that S equals the integral of beta A 2 pi y times the square root of 1 plus the derivative dy dx squared dx. So this is the formula. It is very similar to how we define arc length. So if I go up here, we have the formula for arc length. L is the integral from c to d of 1 plus dx dy squared. So the only difference is dy dx dx dy, but we will be revolving about both axes. So it's a very similar formula that we'll be using. All right, so with that said, let's jump over to MATLAB. So we're gonna solve, let's go back to the book. So we're gonna solve this problem here. It's an example. It's example 1. So it says, find the area of the surface generated by revolving the curve y equals 2 root x for 1 less than x less than 2 about the x-axis. All right, so, and then they go on to solve this. All right, so let's go over to MATLAB. So I've put in the problem in MATLAB also, and I've made the function. Okay, so now what we're gonna do is we're gonna put in some code finding the derivative of the function. Then we're gonna make the discriminant how they have in the book. So this thing here, and then we're gonna square that, and then multiply by the function, and then lastly by 2 pi, and we're gonna take the integral. All right, so let's do that. All right, so let's come back to our code. So what I've done here, I've taken the derivative here of the function with respect to x. dy dx is derivative of y. Okay, so and then next is I've made an equation which has the discriminant. So I'm taking the square root of 1 plus this derivative squared. And then I've made another equation where I multiply the equation 2 by the y function, which is over here. And then we're going to jump to our surf function. So surf2 is now the integral of the equation 1 would be y times the discriminant from a to b. And then surf1 is 2 pi times this function here, this equation surf2. 2 pi times surf2, and then lastly I simplify surf1. All right, so what we need to do now is we're going to put in some fprintf commands. So fprintf. So we can say, let's see, let's make a new line, and we'll say the surface area is exactly let's do some formatting. So x/n, and then outside of that we say surf. All right, so let's go ahead and run this, see what we have. Oops, I forgot a comma here. Let's put a comma. All right, let's go ahead and run it. Oh, I need to symbolically define x and y. So we say syms xy, like this. All right, let's go ahead and run it again. All right, it says the surface area is exactly negative 8 pi times 2 times square root of 2 minus 3 times 3 to the 1 root 3 divided by 3. So let's compare that to the book, see what they have. in the book. So they have 8 pi over 3, 3 root 3 minus 2 root 2. So we have negative 8 pi because we have 2 root 2. We start with 2 root 2 minus 3 root 3. So we get the same answer. We also can get an approximation answer. So let's clear this. And we can comment here. Or actually just print this. Let's copy and paste that. So we say it's approximately. Let's put approximately. And then this would be now percent 0.2f or something. So 0.4f. Percent 0.4f and \n surf. So let's see what we have when we run it. All right, so this is, I actually want to show both exact and approximation. So if you want an exact answer, this is the answer here. It's a long answer, even simplified, and the approximation to 4 decimal places is 19.8358. So this is revolving about the y-axis, about the x-axis, sorry. So now we can do about the y-axis. It's very similar, but we have different functions. So let's comment all of this. Let's put the syms back there, leave it back there. But our function is for the second problem they do in the book. So the formula for about revolving about the y-axis is very similar, but for every where we see y, we change it to x. So it's 2 pi x times the square root of 1 plus dx dy squared. This is similar to the arc length function, and it's they put it in form of g of y in the second line. All right, so for the example 2, we have x equals 1 minus y. From a is going to be 0 and b is going to be 1. So let's put that in there. So we have x equals 1 minus y, and then a equals 0, b equals 1. All right, so let's see. Okay, so we're gonna revolve. So we're gonna solve this example here. Okay, find the lateral surface area. So let's go to MATLAB. All right, so what I'm gonna do is I'm gonna type in my code and I will explain what I've done. And then we can just copy and paste this line of code. That's going to stay the same. And we can uncomment it. So we can uncomment this. All right, let's clear the screen. And we can now run this code and see what we get. All right, so I had some issues when I made this code. For equation 2, I typed it in incorrectly. It needs to be just like this one up here. But instead of dy dx, we have dx dy. So the code is very similar to the one above it for revolving about y-axis, except that wherever we have y, we change it to x. We have dx dy instead of dy dx, and so on. But everything else basically stays the same. So let's run this code and see what we get. So the surface area is pi root 2, or it's approximately 4.429. And if we compare that to the book, their answer is also pi root 2. They don't give an approximation. So that's how we make a MATLAB program solving surface area of revolution.